Okay. All right, so who did I say was first?
Number 2.
Number 2. Solve using the inverse method. Now, this is totally calculator. Solve using the inverse method is a calculator problem. Okay? So what that means is you're going to write your matrix equation, and then you're going to multiply both sides of it by the inverse of the coefficients. So that's a lot easier than it sounds. So this is a big one. When you write your equation, this is number 2. When you write your coefficients, we're going to have A, B, C, D. So I have 1, 1, 1, 1. Now, when something is missing, you're going to put in a 0. And of course, you're including all negatives. All right, so does that coefficient matrix make sense to everybody? If we're using the inverse method, then this is how you start. So we're going to call this A. This matrix A. And then we're going to type in, when we get to that point, a separate matrix, call it B, and it's going to be 10, 7, negative 1, and 0. This is all going to be done on the calculator, so what you have to write down in the workspace is the matrix of coefficients and the matrix of constants. Then, to get the answer, you're going to take A inverse times B. And that's going to be done on the calculator. And that's going to give you an answer. Okay? So let's put in matrix A on our calculator. So second matrix, edit. What are the dimensions of matrix A?
4 by 4.
4 by 4. And we're going to put those numbers in. Since this problem is done entirely on the calculator, please practice with me, because otherwise you won't be able to do it. And that would not be good. Your matrix menu is weird in that once you get this in, you press -3 and enter, you have to quit. So you got to go out. Now we're going to go second matrix again. We're going to go back in. Whoops, second matrix again. And we're going to put in this one. So we're going to click across to edit. But this time, be careful. Let me do this again. So we're going to click across to edit. And before you press enter, go down to B. You already put in your A, right? So now we got to go down to B. And what are the dimensions of B? 4 by 1. So we'll put those numbers in. Is that a 10? I can't even read it. 10. And then once you get B in, then you're going to second quit again. Go out. Now, go back in, third time on this problem, second matrix, and hit enter, because you need A. And names the matrix and calls up whatever name you want. So in this case, it's A. Then press that button, the button that has this on it, press that button, and then times, second matrix, put down to B, and hit enter. So your screen should say this now. When you press enter again, it gives you the answers. Okay? So that's all you have to write down. These are the two matrices that are going in. This is the operation you're going to do. So second matrix, enter, will pull up A. press your inverse button, times second matrix, click down to B, enter, equals, there we go, that's it. Okay? Inverse method? Okay, Abby?
Can we do 7K?
Yep. 7K. Oh, did we never talk about that maybe? Okay, it's awesome. It shows up on a review sheet. I never bothered to talk about it. Okay, well, it's easy. Luckily, it's super, super easy. So it involves matrix A, so I'm just writing down matrix A. And then we have talked about what this means, right? Or that could be a little t also. Any t up above like that, what does that stand for? That's the transpose. So that takes the matrix and like flips it on its side. So what was a row becomes a column. This is something different. See, it looks different. It's out in front. It's a T, R. This stands for the trace of A. And in this matrix, the trace of A is 1 plus 1 plus 5, or 7. So in layman's terms, we would say it's the sum of the entries on what's known as the main diagonal. So it's 1 plus 1 plus 5. Now, you know that you can only do a determinant or an inverse if it's square, right? Same thing with the trace. You can only do a trace if it's square. So if I wanted the trace of this matrix, this is square, I would add up these numbers right here. And whatever I get when I add them up is the answer. Okay, so it's a new word, new idea, but it's so easy. We just add those numbers up. All right, so now I'm ready. I have boys back here. Ethan?
Can we do 6?
6? Now, 6 is exactly like what I just did here on my calculator, only I'm going to do it by hand. All right? So I'm going to do exactly the same setup, but I'm going to have to do it by hand this time. So I'm actually, Ethan, I'm going to leave this right here because this is what I'm going to end up doing. So I'm going to leave that. But I have a new matrix A and a new matrix B, and I'm not going to use my calculator. So A is 1, 1, 2, negative 3. And B is 5, negative 5. Is everybody okay with that? Now, if I'm not using my calculator, then I'm going to have to find this all by myself. And I should know how to do that. That is the inverse of a 2 by 2. So who remembers how we start that process? Find the determinant. So the determinant, which is what the vertical bars mean, that means determinant, is negative 5, negative 3, minus 2. Okay, then what happens?
Then you've got to flip 1, negative 3, and then change.
Yeah. This is where we do that random thing where we make a new matrix by switching these guys and changing the signs on those. So I'm going to have negative 3 and 1 and negative 2 and negative 1. Is that right? Then I'll take all of these and divide by negative 5. And simplify as necessary. So A inverse is going to be right here. This is A inverse. So 3/5, 1/5. And 2/5, negative 1/5. Now, this actually is a problem also down in number 7, right? So you might have to do this twice. Find this inverse, so make sure you know how to do it. Donovan?
If we can't use our calculator, it'll be on the calculator section.
Yep. This one will. The big one we did earlier would be on the calculator section. Okay, now, that's A inverse, so I need to multiply it times B. So remember, this is a 2 by 2. This is a 2 by 1. So when I multiply them, I'm going to get another 2 by 1. So I'll take row 1 times column 1. So 3/5, 1/5 times 5, negative 5. Now, remember, this is like 5 over 1. So what do you get here? 3. And this is 5 over 1, so that's negative 1. So we have 3 minus 1,
2.
which is 2. And then take these two, 2/5, negative 1/5, times 5, negative 5. So row times column. So that's going to be 2
Plus 1.
plus 1, I think. Isn't that going to be 3? 2 plus 1? And that's the answer to the problem. 2, 3. That's the answer to the problem. Okay, Ethan? You okay with that? All right, so the two questions you'd asked me about, or the first one and now this one, both involve the same procedure. The first one we did on our calculator because it was so big. The second one we did totally by hand because it's little. Same idea right here. Okay, is it out this question, sir?
Oh, no.
Okay, wait, I still have to get Thomas.
Mine was answered.
Okay, good, all right.
Can we do 9?
9. Sketching, showing all the asymptotes and intercepts and all that stuff, okay. So this is on the no calculator part. So you're gonna have to be able to manage this picture all by yourself. And this should be easy, because it was on the test earlier in the year, and it may have even been on the semester exam, I can't remember. First thing you should do always is what? Factor. Speaking of which, I'm subbing for freshmen today, and we're factoring. With a leading coefficient. So all days that I have to be with freshmen on the board. I'm sure it'll be great. It's also the activity period, so I get to do a tornado drill with them and take them to the assembly.
Where would you?
We do. Tornado.
During the activity.
At the beginning of the activity.
So we're in class.
Yeah, you go to class. Go to E period. Have a tornado drill. Then, after that's over, then we go to the gym and watch basketball. Okay. So the first thing I always want to do is factor. Maybe something will cancel. And if something cancels, then I will have a hole. Now remember, nothing cancels here, so this is not going to have a hole. But if you had a problem that did factor and cancel, this right here would tell me that my hole was at the point where x is negative 1, because that's what canceled out. And then to get y, I would plug it in what's left. So negative 1 minus 1, and negative 1 plus 5, so negative 1/2, that would be my hole. Right? This one doesn't have 1 because nothing cancels. All right, it does have asymptotes. Where are its asymptotes?
2.
Well,
The horizontal asymptote.
the horizontal asymptote is at y equals 2. And you saw me pause when he said 2, because 2 isn't going to get you full credit. You got to say y equals 2. Because of 2x over x, remember that little rule? All right, what else? Where's the other asymptote?
Vertical asymptote is at negative 1/2 or 1/2.
vertical asymptotes at x equals 3. Because vertical asymptotes happen when you're undefined. And the only time you're undefined is when your denominator is 0. And what makes it 0 is 3. Now, what you're talking about, sir, when you said negative 1/2, you're looking at your numerator, and that gives you your x-intercept.
Okay.
Because if you put in negative 1/2, that fraction is going to equal 0. 0 on top means 0. And then to get my y-intercept, I'll stick 0 in. So that's going to be at negative 1/3. So all of the important stuff is there. So now you just hopefully have enough that you can connect the dots. And I think you do, Gary, you've done enough of these that you can just see it right here. Remember that the curve is going to approach its asymptote. Okay, so the farther out you go, the closer it's going to get to this and this. Okay, half the picture, where's the other half?
On the other side.
On the other side, kind of opposite it, right? Right here. And the same thing, up and out. Right? Okay, good questions. Who else found something?
Give me number 1, number 5.
Number 1. Okay, this is a calculator problem, okay? So what you have to write down, this is problem number 1. This is problem number 1. This is a little bit different what you write down because you write down the entire one matrix and you put every number down there. So this is called an augmented matrix. I write down the augmented matrix. There it is. This is different than the inverse method. This is Gauss-Jordan reduction, which is when I'm going to use the RREF button on my calculator. So one matrix. So this is written down on your paper. And then, so on the paper, I have written a matrix with no numbers in it, just a matrix equal to another matrix. You're going to fill this one in. This is the original. This is what goes into the calculator. And then you're going to tell me what comes out of the calculator. And then you're going to give me my answer, my x, y, and z. So, second matrix, over to edit. How big is this one?
3 by 4.
3 by 4. And as soon as you get it in, just like always, when you finish a matrix operation, you have to do second quick. Now I'll go back in, second matrix, over to math, all the way down to RREF. So I'm going all the way down till I find RREF, press enter. And then second matrix, A is the very first one, that's what I want, A, and enter. Now, I got fractions, or I mean decimals, did you?
Yep.
Okay, when that happens, just hit your regular math button and change them into, oh, whoa.
It's the one with zeros on the bottom.
Yeah, okay, we talked about that, didn't we?
Yes.
Okay, well, this is a shame, but let's go ahead and write it down because we gotta be able to deal with it. So this is not gonna be my answer. Who remembers, first of all, is that what you got when you changed into fractions?
Yes.
Okay. Remembering that when you set up your original matrix, the columns were X, Y, Z, and equals. So if we look at that, when we look at that, the top row says X plus 2/3 Z equals 8/3. Would you agree with that?
Yes.
And the middle row says y minus 5/3 z equals 13/3. What does the bottom row say?
0 equals.
Well, it says 0z equals 0, right? When we write our answer, that literally means if 0 times a number is 0, can't the number be anything? So the way we reflect that, or the way we write that is, we just say z equals z. Z is whatever. This means z can be anything. Right? 0 times 5 is 0. 0 times the square root of 17 is 0. Z can be anything. But then y is going to be 13/3 plus 5/3 z. If I get y by itself, I'll add this over. So whatever my y is, it depends on what I pick for z. Does that make sense to you?
Yes.
And then the same for x. X is 8/3 minus 2/3 z. So you remember how we wrote our answer? We said, okay, x, y, z. The two-part answer, which makes perfectly good sense. Because if you look at this, for example, isn't that a two-part answer? So the number part is 8/3, and the z part is negative 2/3 for x. And then for y, the number part is 13/3, and the z part is 5/3. Now what about this one? What's its number part?
0.
0, doesn't have a number. And what's its coefficient on z? 1. So there is your answer. That's called a parametric solution. Infinitely many answers. And it means your planes are intersecting in a line. This is a line. Believe it or not, that's a line. Okay? That was a good problem. Now, in a perfect world, this is not what would happen. What I thought was going to happen is I would get a matrix that looks like this. And when I get a matrix that looks like that, then I know my answer is 1, 2, 3. But when this happened, then we knew we were in for big time. Donovan? Okay, who asked this question? Are we okay with that? That's kind of complicated. You all right with that? Okay. Which one? Number 8. We need the partial fractions. No, we did partial fractions. Why did you cross that out?
I don't know. No, I thought that she crossed it out.
Right. Who remembers step 1 of a partial fraction decomposition? Alexis?
You need to factor the denominator.
You need to factor the denominator. Don't mess with your numerator, but factor your denominator. So my denominator is going to factor into x minus 4, x plus 1. Did you agree?
Yes.
So I'm going to set up 2 partial fractions. So this is like the big fraction. And I'm going to break it apart into 2 littler ones. One's going to have a denominator of x minus 4, and one's going to have a denominator of x plus 1. I have no idea what these numerators are, so traditionally we call them A and B. You can call them whatever you want, not x. Don't use x because it's already in the problem, but whatever you want to call it. All right, everybody good so far? Okay, what now? Sir?
So you have to multiply your numerators by like both of the denominators?
Exactly.
Or canceling?
Exactly. That's the whole goal. We're going to cancel out and see what we have left. So I'm going to multiply this numerator by x minus 4 and x plus 1. This numerator by x minus 4 and x plus 1. x minus 4, x plus 1. Now, over here, the whole shebang cancels. So all I have left is 6x minus 34. Does everybody get that?
Yes.
Here, just this part cancels. So I'm gonna have my a times my x plus 1. That's what's left. And then here, that's gonna cancel. And I'm gonna have my b times x minus 4. Now what? Alexis?
You got to distribute the A and B into the x plus 1.
Exactly, so I'm gonna start distributing. So I have 6x minus 34, and that's gonna equal ax plus a plus bx minus 4b. Everybody okay with that? All right, now this is the part where sometimes we get confused and we shouldn't. On both sides, you have plain numbers, no x's. On this side, the plain number is negative 34, right? On this side, the things with no x's are that a and that minus 4b. So this and this and this all have no x. So the ones on the left are equal to the ones on the right. Okay? Now, do the same thing with the x's. On this side, I have 6 x's. On this side, I have a plus b x's. Now what have I got? System of equations that can be solved however you want. Substitution, elimination, Cramer's rule, inverse method, I don't care. Solve it somehow. You won't have a calculator, so you're not gonna be able to do that. So you probably know what I'm gonna do. I'm an eliminator, yeah. So I'm probably just gonna multiply that top row by a negative. So it looks like when I add 40 equals 5b, so b is 8. And then, since a plus b has to be 6, it looks like a must be what? If 6 equals a plus 8, then a has to be negative 2? I think this was a quiz question. And I know I told you before we took the quiz that that is not the answer. And some of you still wrote that down as the answer. The answer is the partial fractions. So the answer will be negative 2 over x minus 4, because my a is over x minus 4, plus 8 over x plus 1. That's the answer to the question. Find the partial fractions. There they are. Hurry up. Okay? All right, who else? Anything else we need to look at? Reese.
Number 5.
Solve. Well, it doesn't tell me how. So Reese, how do you want to do it? We have a system of equations. It's no calculator, so we can't use a calculator, but other than that, you have lots of choices. What do you want to do with that?
I first factor the bottom one. Or no, I put x equals y plus 3.
Okay, so x equals y plus 3. It's not perfect. Sounds to me like she's going to do substitution. Because if x equals y plus 3, she can take that guy and plug him in right there.
Yeah.
So you're going to have y plus 3 squared plus 2y equals negative 3. Good? Now what? Foil it. Gotta foil it. Foil it. Make sure you foil it. This is gonna be a quadratic equation, so we gotta get it set equal to 0. So y squared plus 8y plus 12 equals 0. Now it's quadratic. You can use the quadratic formula, or you can factor it, or you could complete the square, whatever you like to do. I think it does factor, doesn't it? 6 and 2. 6 and 2. Now, that means that in your answer, which is ordered pairs, points, where do these things cross? The y coordinate is either -6 or -2. Okay, now we need to find the x. We're not done. This is not enough. So we're going to go back and say, okay, if y is -6, you can plug it in wherever you want. This is easier here for me. So if I plug in -6, then it looks like x is -3. But if I plug in -2, it looks like x is 1. Those are the points of intersection. When it says solve, substitution fine, elimination, Kramer's, because of the squared, I'm a little limited. I couldn't really do Kramer's rule with that one, but yeah, that's great. Okay? Sir?
Oh, no, I was like trying to figure out why 2 lines are crossing in 2 different places, but the second is a quadratic.
Exactly, it's parabola. 2 lines aren't going to cross in 2 places, but a parabola and a line, yeah, right. Yeah.
We did the 6y.
When you FOIL that, y plus 3 times y plus 3,
Oh, I see.
yeah. Don't be one of those people that writes y squared plus 9, okay? You see all this gray hair? Yeah. Don't do that. Okay, now no one has asked about the word problem, the linear programming problem. Do we know what we're doing there?
Plug in the numbers, matrices, multipliers.
Yeah. We don't need to do that? We got it?
Can we do it on our own and then check it?
We should have already done that. Yes, you can do it on your own and check it. Is there any other question you have? I've got a few homework papers I want to turn back. Anything else? Ollie?
Number 2.
Number which one?
Number 3.
3. Solve using Kramer's rule. Now, it says no calc there, even though they kind of got off. So we're going to solve using Kramer's rule. Okay, so who remembers what we got to do if we're solving using Kramer's rule? Izzy?
You take the first number of the division and you make a matrix, so it would be 2, -3, 1, and 5, and then your second matrix is going to be 8 and -7.
Okay, well, hang on. Oh, wait a second. Wait a second. Okay. Now, I can make a matrix out of 8 and -7, but I don't really use that in Kramer's rule. These numbers are going to get pasted into this one. Okay, so this is the first thing I do. This is the coefficients, and I'm going to find that determinant, so that's going to be 10, 13. Right? And then do you remember where what the 13 is? What's the significance of the 13?
It's, your final answer is divided by.
It's the bottom of the answers, right? So my answer is going to look like this, mid-quarters pair, but these are going to be fractions, and they're both going to be over 13. Now, the numerators, like she said, are other determinants. I'm going to take that 8 and -7, and I'm going to paste it on the x's. These are the x numbers right here. So I have 8, -7, and then my -3, 5. I'm not moving anything or changing anything. And then for y, I'll do the same thing, only I'll paste here. So it'll be 2, 1, 8, -7. negative 22. Now, if those reduce or simplify in any way, you need to do it. Those don't, so we're done. Okay? All right, anything else from the sheet? All right, you got the rest of the period to work on your own thing there, asking your neighbor or me for help.